gravitational force. Now, today's point is Earth gravitational acceleration. This acceleration is created by the Earth's pulling force. We call it also, it is the gravitational force. Our Earth exerts gravitational force on object near it. Whatever may be object near to the Earth, it is influenced by, acted by, under the force of gravitation of the Earth. So, we call it always gravitational acceleration as well as gravitational force. The Earth exerts gravitational force on object near it according to Newton's second law. You learned in the last year, Newton stated 3 laws about the motions. That is, according to of the second law of motion, a force acting on a body result in its acceleration. You know that law. If any force act on any body, if that body accelerates, you know acceleration is the changing position. It is the changing velocity. That's why our Earth also continuously act force on that object that is nearby it. Thus, the gravitational due to the Earth, we are going to see only about the acceleration and force act on the body of the Earth. Thus, the gravitational due to the Earth on the body results, उसका नतीजा, उसका परिणाम results in its acceleration. It changes its acceleration. This is called acceleration due to gravity. Due to gravity, that means it happens, it created, it is changed due to the force of gravitational of the Earth act on it, and is denoted by small g. It is represented by small g. Thus, the acceleration is a vector quantity. You may know about the quantities. There are many quantities in the physics. Basic quantities, fundamental quantities, derived quantities. And then furtherly, vector and scalar are the quantities, such as scalar quantities do not have direction, but the quantities which are termed as vector quantities, they are explained with magnitude as well as its direction. So, acceleration is a vector quantity because this happens, this motion, this acceleration in the direction of force act on it. Here the direction is also important factor. So, it is called a vector quantity. As gravitational force on any object due to Earth is directed towards the center of the Earth. every body near to the earth on which force, gravitational force act on it, this pulls towards the earth, and that body accelerates to the center. Maybe it is not reaches fall on the center, but direction of that falling body, direction of that accelerating body towards the center of the earth. Because of, you learned in the last videos, the gravitational force of the earth is concentrated on the center point of the surface of the earth. So it's direct towards the, travels towards the earth surface center, toward the center of the earth, that is vertically downward, because falling body is falls and its direction is vertically. Now we see the value of g, that is the gravitational acceleration on the surface of the earth. How it is calculated, the value of g on the surface of the earth. We can calculate the value of g by using Newton's universal law of gravitation. That is it. F is equal to g upon r square. Universal law of gravitation, that is we have already learned in the previous class, previous lectures. Gravitation, an object of mass m situated at the distance r from the center of the earth. Center is considered, actually the center of the earth we cannot easily confirm, easily find out. The law of gravitation given, F, that is force, is equal to g, universal gravitation, m, mass of the planet, mass of the earth, and small n, it is the mass of the object, and r, this is the distance of the object from the center of the earth, its scale. Then f is equal to mc from 3 and 4. Fg, it is the mass into gravitation, and when you use the value of f, thus mg is equal to g m upon r square. Here, so g is equal to gm upon r square, that is 5. G is equal to gm upon r square. Here, so putting the values in the formula, g is equal to 6.67 into 10 raised to minus 11. It is the value of universal gravitation. Into 6 into 10 raised to 24, it is the mass of our earth. Upon r square, the radius of the earth sphere, 6.4 into 6 raised to 10 raised to 6 bracket square. So g is equal to 9.77 meter per square second. If the object is situated, it is the situation. There is r, the radius of the earth. Thus the value of g on the surface, that is 9.77 meter per square second. You know the unit, SI unit of G is the meter square second. It is the SI unit of the Earth. In the acceleration due to gravitation of the Earth, here it is an important point that this acceleration depends only on the mass. Mass, in capital, that means the mass of the Earth, mass of the any planet, and radius r, it is the radius of the Earth or any planet of the Earth, and so the acceleration due to gravity at a given point, at a given point, that means something is hiding this statement. We will see later. So, at a given point on the Earth is same for all objects. Maybe objects are different, their properties too different, their mass, their density, their volume may be different, but the value of Z on the Earth at the given point is not variable. It remains the same. It does not depend on the properties of the object. Just I told you properties, that means the volume of the object, density of the object, mass of the object. It is not depends upon that property, that objects. In the last point I told you, something is hidden in the statement, and that statement was the gravitation acceleration is same at the given same point on the Earth, because of if the point on the surface of the Earth is changed, there is also changing the value of C. So, maybe the value of the same object on the same point is constant or same, but if the surface point on the Earth is changed of the same object, its value also changes. So this point is variation in value of C. In them change along the surface of the Earth. You know, our Earth's surface is very large. Maybe its center point is not found out, but it has a surface center, and if it goes somewhere on the surface of the Earth, that means in different points on the surfaces, the value of the same object also changes, and the value of the gravitational acceleration also changes. the value of G is not same on the different point on the surface of the earth. This is clear-cut statement. The value of G is not same on the different point on the surface of the earth, because the shape of our earth is reason, is cause. Shape of earth is not exactly spherical. Our earth is not exactly spherical. It is slightly elliptical. These are the poles, North Pole and South Pole, and it is the equator. Observe it. It is not a complete spherical shape. And thus, so the distance of a point on the surface of the earth from its center, suppose it is the center of the surface. The distance on the equator and distance on the pole, both poles, south and north. This distance R and this distance R are variable. Earth from its center differs somewhat from place to place due to its rotation. The earth bulges at the equator, and flatter, it is less distance, and flatter at the poles. Its radius is largest at the equator and smallest at the poles. Suppose these are the poles. This is it is equator. R and R. These are different. So distance from the center point of the earth to the equator and to the poles is different. At the pole, the value of G is the highest, that is 9.832 meter per square second. On the pole, both poles, because distance is less, R, value of R is less. At the pole, and the decreases slowly with latitude, it lowest subsecond, lowest, because distance from the center point is increased. That is why the acceleration due to the gravity also goes decreasing, and that is lowest 9.78 meter per square second at the equator. This happens. These are the representing 2 points on the earth, equator point and points on the poles. But from the center points at the different surface points, there is a slightly changes the value of Z. B. This is another point which causes the changes the value of the Z. that is change with height from the earth surface. As we go above the earth surface, that means from the above the earth surface, the value of r in equation increases and the value of g decreases. We say we goes higher from the earth surface, that increasing distance above the surface and then decrease the value of g. It is inversely proportional to the height. However, the decrease is rather small for heights in the comparison to the radius of the earth. That height may be very small, which are small in comparison to the earth's radius. For this example, remember the radius of the earth is 6,400 kilometers. That is in meter 640,000 meter. That means 6.4 into 10 raised to 6 meter. If an aeroplane flying at a height 10 kilometers above from the earth's surface, its distance from the earth's surface changes from 6,400 kilometers to 6,418 kilometers, only 10 kilometers more than the radius of the earth above the surface of the earth. And change from the earth's surface, this in the value of g due to it is negligible, because distance is equal to only 10 kilometers than the radius of the earth, and this distance is very small compared to the radius of the earth. So the changes, the value of g is negligible, it is not considerable. On the other hand, we launched the satellites above the earth in the orbits, and that distance is very large, far away from the earth's surface compared to the radius of the earth. That is considerable changes in the value of g. When satellite reaches at the orbit of the earth, its g decreases considerably. Its g value of gravitational acceleration, it becomes very less. See the table in your textbooks 1.7. In this table there is a given the above high point from the earth's surface and the value of g. Now it is enough today's lecture. I will continue to the next lecture, next point, value of g. Namaste.